All right, kicking us off after this break, we have Drishti Jain. Drishti Jain is a software engineer and global conference speaker who believes in democratization of technology knowledge. She's presenting Beyond the Vector Database, building a RAG stack that actually stays fresh. Real-world architecture for retrieval systems that evolve with your changing documentation. Please join me in welcoming Drishti to the stage.
Thank you. So hi everyone, I'm Drishti Jain. This is going to be a very interesting talk. Before I get started, let me quickly talk about myself. That QR code has everything that I do in my life, including a link to my book. So my book is on Laravel, which is an open source PHP framework. I recently had like a 1-year celebration of my book being out there. I'm a software developer and machine learning engineer. I'm a published technical book author, and I'm a social entrepreneur. So I have a nonprofit organization back in India, wherein we work across environment, education, and healthcare. I'm an international tech speaker. I like to share anything and everything that I'm doing. I believe that in the tech community, the biggest strength we have over any other, say, community is that there's so much out there to share and learn from each other. And the more you share, you realize the amount of knowledge you gain back with those conversations. And I'm a career coach as well. So I have something called Skill Up with Drishti, wherein I help anybody who's getting into tech, growing in tech, moving different career paths across tech. And yeah, flew in from California for the talk today, so excited to be in Nashville. I've been exploring Nashville since yesterday evening. It's so pretty, it's so wonderful. It's like a dreamland. Like, I just love it here. So yeah, thanks for keeping the conference in Nashville so that I could visit. So a quick summary of what RAGs are. A lot of us use RAGs in our daily lives, but technically speaking, what exactly is RAG and how does it differentiate from your normal LLMs? So with RAGs, there are two components, the retriever and the generator. So retriever is something, you can think of it in simple terms as when you have to pull relevant documents from your external knowledge source, that is just retrieving. And generation is using LLMs to generate answers based on the retrieved context. So when you combine both of this, that is wherein RAGs come into place. And a lot of benefits with RAGs. First, the very important one is factual grounding. Things keep changing very frequently. You want your answers to reflect the recent information. You need to be factually correct. And that is something that RAGs provide us with. You can have domain-specific responses, better interpretability. You have LLMs which have the power to do everything, but what should their knowledge base be like? So combining both of this is the power of RAGs. A lot of us already use RAGs on a day-to-day basis, develop a lot of things out of it. But a key reason why we use it is because it helps overcome the knowledge cutoffs of LLMs. It might be trained on data that's existing with the LLM and might not be very relevant to the specific use case you're working along with. You are able to customize generation using your data. So you have the power of LLM, but for yourself. So like a domain expert or a subject matter expert for your use case. And it is safer and more up to date than just pure prompting. You'll have very specific results that you want for yourself or your use case. So why does freshness in RAGs matter? What do I exactly mean by freshness? So freshness is important so that there are no hallucinations from your previously indexed data. A very simple concept that you can keep as a generic overview of the complete talk. If you do not have a fresh RAG stack, you will miss updates which will lead to user mistrust. Imagine on your website, you are providing solution for a particular tech component, and you have different versions that have evolved, but maybe your chatbot that an end user comes and talks to understand whether to buy your product or not is based on, say, version 2, and you're right now on version 4. That way, the user really doesn't know the current capabilities that your product has. And that would lead to missed revenue, lost user trust, and you do not want that. So having your RAG stack fresh is important. An example from real RAG failures are, you must have read this online as well. A lot of people went along and in their internal databases, they wanted to say search, they're traveling for work, like business purposes. They want to know what the company policy is for reimbursements of your travel. The RAG returned results which were like a year old, because that is when the company internally built their RAG system and it wasn't really updated. Whereas now the process had completely changed. So that led to a lot of confusion between the employees who were booking their business related travel and what the intelligent travel bot was answering to them. So you don't want things like that. So things like company policy, that is a very good example of what keeps changing very frequently. It can change every quarter, it could change every year, every 6 months, you never know. So you want your RAG to be very, very updated. And that is why it has to be fresh. If you look at a traditional RAG setup, at a high level, we have a vector DB, we do chunking, and we have an LLM. And we assume that there's a static knowledge base. We don't assume a traditional RAG setup to be like a real-time influx of data continuously that keeps updating, because it's hard to maintain, it's very costly, and you would want to keep your costs a bit down. And it works well only initially, but the major task comes in how is your data source or your knowledge base to be as relevant and up to date. RAG in the real world, like internal documentation changes weekly. With the influx of using AI in our coding workflows, there is always a re-architecture of any system that you're building at work or in your personal project. In all of those cases, there's a constant change with your internal documentation. Wikis, your Confluence, your GitHub readmes, your product specs, all of these keep changing very frequently. And this requires a continuous update and quality assurance. So these are the major key challenges that we want to solve throughout this talk of how you can also incorporate it in your RAG workflows. So our goal today for all of us is to have a RAG stack that updates without fully re-index. Like the simple solution is you run like a cron job every day or like every week, and you keep re-indexing it. But think about it, like if you have a very large set of knowledge base, and if you keep re-indexing it, is it the most efficient way? No, right? We want better ways so that we are saving up on time, on cost, and doing it as and when only it is required. We want to track changes, freshness, and versioning, so that we are optimizing the cost and we are optimizing the quality, so we want a good enough trade-off. An overview of the RAG architecture. So this is a quick sequence diagram that's there in one of the NVIDIA blogs that gives us a quite good picture of what RAGs actually look like. If you see, a few of the components that we are going to look into today are going to be, you have your knowledge base, you pre-process the documents you have, and then it goes to your embedding model and then your vector DB. As an end user, you are exposed only to the chat bot, the web app, and that gives the user query, which again goes back to your embedding model, your vector DB, and the LLM in order to give you a concise single answer so that you're able to get the desired information you need. Now, what are the key challenges that come with it? You need to avoid redundant reindexing. You need to prevent silent embedding drift. And you need to retrain at the right time so that you're prioritizing the right and the fresh answers. So this is a quick, I have 8 steps in it. And I have a bit of code example as well so that you get a sense of what does actually making your RAG stack to be fresh look like. So the very first one is change detection. You need to detect if a document has changed since the last indexing. And that way you're able to avoid the costly re-embedding cost that you incur. A technique to do that is checksum-based detection. You would compute the hash per text chunk. You'll do it in chunks so that you're not doing it for the whole part, but doing it efficiently. And you compare it with the previous version. This makes it to be stateless and efficient. A quick example is for a checksum-based detection is like this, wherein I'm downloading the raw docs that I have. I chunk them I compute their checksums, compare it to the previous versions, and only embed plus index the changed chunks. That way, at a chunk level, you are re-indexing instead of re-indexing the whole document level part that you have. And in code, it is as simple as this. You're basically applying a checksum logic per chunk, and that gives you any kind of change detection done. The second is embedding metadata and versioning. So firstly, you want to track the embedding model, the timestamp, and the source. And you want to avoid accidentally mixing of incompatible embeddings. While doing all of this, it might very easily come off as it's so easy to find the right chunks, it's so easy to reindex as soon as I find something that is different from my previous version. But you also want to ensure that your embeddings are not, like they are compatible. They should not be incompatible. Otherwise, you'll run into more issues and that will just delay your process. And you'll lose like a lot of time in doing that. And that is why versioning matters. Embedding model upgrades silently alter vector space, and the retrieval accuracy degrades if you're not actually versioning it correctly. Once you have a version, it will also help you track what changes were done. You're also then reducing your change metrics and just going from one version to the other. Let's look at embedding versioning. So with embedding versioning and drift detection, what I'm trying to do here is to have a new index and then pass something called changed. I want to do it at a chunk level and also be able to tell, as a developer, be able to identify what parts are exactly changing, how does my embedding versioning change, and with this versioning, what will also help is in case you come across a different format, you're also incorporating it. So later on, like say a few months down the line, you don't have incompatible like versioning of your embeddings. After you have done embedding changes, this semantic change detection. Sometimes content changes very subtly. There might just be a very subtle change, but it has a very huge impact, which at its raw, your RAG would not really consider it to be exactly different, but because it has semantically differed, you as a human can understand, but you want a way so that your RAG also understands the same. Like the text looks different, but the meaning is same, or it could be vice versa. So a technique for it is semantic diffing. So there are sentence transformers to compare old versus new chunk meaning. So a lot of sentence transformers are already out there. Just that if you have the knowledge, you'll use a sentence transformer so that you have semantic diffing and not just like text-based diffing. A quick example with that is, so in Python, we already have sentence transformers, and then you can import sentence transformers, apply it to your old chunk, new chunk, and set a threshold based on what works better for your use case, and you'll have a semantic diff. It is much, much better and efficient than just doing a normal diff across your different docs or data. And another good coding practice that you could incorporate with semantic diffing on changed chunks is to like tag them. So if you have an old chunk and a new chunk, it's instead of just updating the same chunk, if you keep it as a new chunk, you would know that you did a semantic diffing on this, and in the long run, as a good clean code practice, it will be easy for somebody who takes over your work, say a year down the line or 6 months down the line. It'll be easy for the next developer, so that we are not creating technical debt for the next developer as well. Because we as developers don't like technical debt, right? It's also our duty to ensure that the next developer doesn't face that issue because of us. Next is indexing with intelligence. So only index meaningful changes and reduce cost on different API providers. The success with RAGs will only be sustainable if we are able to justify good cost matrices to the business. Otherwise, however good of a technology, you'll not be able to use it in your day-to-day work if in the longer run it's costing the business a lot. So if you index with intelligence, you'll be able to optimize on the cost. The architecture for a normal index pipeline as a whole looks something like from your text, you go to the chunker, then you go to change detection, then the embedder, and then to vector DB. This will help you create a good mental map of what the flow looks like, and internally to each you can have like multiple different techniques applied. Next is embedding drift detection. So I spoke about embedding drift detection and its need a few slides ago, right? But how do we actually implement it in our RAG workflow optimization or freshness? We want to track the cosine drift between our old and the new embeddings and use alert thresholds. What this will help us do is we'll have a good comparison, a quantitative, actual way to measure what your old embedding versus your new embedding has changed. It's easy to just like go to the flow of saying, yes, of course, my new embedding is very different from my old, but till the time you don't have an actual numeric or a quantitative like metric to measure what has changed, how much it has changed, to put in the retraining cost, it would not work out well in the long run. So using something like cosine drift between your old and new embeddings will help you do that. And why does this drift matter? Any drift that, this is a general industry standard of if your drift is greater than 0.3, the retrieval quality drops, and that is when it is a good threshold to understand that this is a good point of re-ranking or retraining your model. Also, if you see, I mentioned that it is either re-ranking or retraining. It's not necessary you always have to retrain your model. Many a times tweaks to your ranking logic can also help you have newer index documents higher than the old. So it is another way of optimally doing it while saving you training costs with GPUs. So for a drift check, in Python itself, we have average cosine distance as a function directly. And you can use that and then have something like an if-else logic of if the drift is greater than 0.3, you raise an alert, and then you as a developer make the decision of if you want to re-rank, if you want to retrain, when do you want to do that. So a good alerting system will help you keep those ideas in check. The second last step is the retraining workflow. So you want to train new embedding models on your knowledge base. You train the re-ranker on Q&A pairs, and you maintain separate pipelines for embedding model retrain on updated knowledge base, and ranking training on user feedback plus similarity data. So this is a generic workflow which can be customized to your specific use cases. So right now, in the past like 6 steps, we have identified like different chunks that have changed. We know the embeddings are actually different from the old and the new embedding. And now we have made the decision of actually training our model. So retraining our model. So a framework that generally works, so I've used MLflow in this. The steps are as simple as you extract your docs into chunk, you embed your old to your new embeddings, then you fine tune on the new embedder, you evaluate, that is you compute your embedding drift that we saw in like a step or two ago, and then you publish your model if the performance is high enough. What this will help you do is, like, these are steps which can again be customized to the way you want it. You can go more deeper into one step. You can have one step to be like auto-generated based on the current libraries we have, or you can just use everything in the same order as well. And similarly, the ranking flow, if you want to generate training samples, then you would train a lightweight cross-encoder re-ranker. Even this, like if you don't want to train a lightweight cross-encoder ranker, there are a lot of open source encoders out there that you could directly plug and play if that fits well with your use case. And then you would version your model and record matrices. That will help you keep a track of what has changed, how it has improved your performance. And the last but not the least step is freshness-aware retrieval. You want to combine relevance with recency. Many a times we just look at recency. We don't look at the relevance matrice, but recency and relevance are both important. So you kind of want like a weighted scoring between your LLM score and the time decay that has passed with your new documents versus your old documents. And a good way of doing it is for each of the hits that you have, you keep on calculating these scores. So you're keeping a good like a internal table of what matrices have changed how has it improved, or it can also reduce based on the hits. Are the users actually using the results your RAG is providing after the new retraining or reindexing, or they're still clicking on the previous answers? So maybe you thought that it is better to retrain it, but as an end user, maybe it didn't provide as much value. So that will also help you learn for the next iteration you have with new set of knowledge base. With that, now we know what to do from start to end for any kind of new RAG that we have. At the end of this, you'll have a RAG which is fresh. And once you have this whole like 8-step like a process set in, you can keep tweaking it based on how your knowledge base changes. Now, once all of that is done, a good practice is to have some monitoring and metrics. One thing you should for sure do is alert embedding drift and take a decision based on the alert. Don't just automate changes if the drift is greater than 0.3. You as a human are the best person to make the decision and not just rely on code to always go and retrain or reindex or re-rank. So yeah, keep human in the loop in your coding practices. A dashboard, so a metrics dashboard to have like a count of updated chunks, retrain logs, and freshness score. And user feedback loop, so you can have implicit signals like clicks or selections, and that can also help you train the re-ranker. That way you know what things actually are relevant or they're just theoretically relevant. A quick few best practices. So hash per chunk. These are good practices that I've realized over developing a lot of RAGs. Semantic diff is very powerful. I directly use semantic diff over any other diff. Embed with versioning, while it might seem like very normal to like our traditional coding practices, but even with RAGs or AI workflows, versioning can help you a lot. And if you embed it directly with your embedding, it is very easy for you to retrieve, see what is changing, and proceed from there. And score by recency. This is a good score that will help you also understand if changes that you're making are being really used by users or not being used by users, and retrain only as needed. You don't want to always retrain. It has a high cost, a high environmental impact, plus it is a lot of like time-consuming work, wherein you're just relying on your GPUs and hoping at the end of the day, a lot of your weights will change in your retraining. And if your model shifts drastically over, say, 10 versioning, then you also need a way to assess performance and then also go back to your pre-trained versions. So maybe the 9 retrainings were not as useful, and you spend a lot of developer time in it as well. So, and a few mistakes to avoid. Very first one being blindly reindex the entire corpus. It's the brute force way of saying, like, if you ask, say, a Cursor or GPT, like, to format your code and remove it of bugs, it can just delete your code base. That's the easiest way, right? If there's no code, there are no bugs. A similar logic of that is like if you blindly just reindex your entire corpus. You don't want that. Or you ignore embedding versionings, or you don't have metadata tagging. So please avoid these mistakes. And yeah, that's from my end. Thank you so much. Open to questions.
Any questions? Right here.
Thank you. Drishti, that was really cool, and I was really impressed at how that all came together. I have a question, though.
Yes, yes.
I run a product that is a RAG model.
Okay.
It's got 2 million words of the corpus, and we just train it every month. We just update it and do the embeddings model every month. Actually, I think I said that wrong. We don't train it, we just run the embeddings model again.
Okay.
It's worked really well.
Okay.
And we're not spending that much money. So is this approach for a much, much larger corpus, or is this appropriate for our use as well?
It should be very appropriate even for your use case. Reason being, if you're even having your embeddings being generated again and again every month, even though the cost might come off to be small, but there can be other differences that you're not actually identifying. So with semantic diff or like cosine, similarity, like the drift checks, that will help you gain insights as to if even after training your new, even after having your new embeddings, is it actually impacting like the final recency or relevancy scores or not? In case it is not, you might want to just shift from, say, 1 month to 2 months. Like those kind of insights you'll get after you kind of have those checks in place. Yeah. Yep.
So I'm curious if you need to worry about where the chunks, like if the chunks move around, or is that handled in the libraries, or do you need to worry about like if previously the chunk started here and there's new content that started, do you end up with like drift in the chunk sections and that sort of thing too?
So the libraries do handle it, and that is a good point for also things like, I think I had it on the slide as well, something along the lines of, if the text changes, it might not seem very dissimilar at a glance, but the meaning might completely be the opposite. So things like that gets detected in your like chunking. Even if it moves completely, or even if the wording's completely changed, it has moved into two different, say, sections, two different chunks as well. Yeah.
Thank you, Drishti.
Okay.
I really
Thank you.
appreciate it. Another hand.